All right, so the third of my short lectures, kind of like these, they're just quick and easy. All right, so 12.3 is all about logarithms. So what is a logarithm? Well, we skipped inverses, which makes it difficult to explain what a logarithm is, but a logarithm is the inverse of an exponential. So let's just talk about inverses first of all, just really quickly. I'm going to do this, very brief. But if I have addition, okay, if I want to get back to x, if I take x and add 2 and I want to get back to x, I would do the opposite or the inverse and I'd subtract 2, right? So if I added 2 and then subtracted 2, I'd still have x. So addition, subtraction are inverses of each other, right? Multiplication and division are also inverses of each other. Okay, if I double x and then take it in half, I get back to x, right? And we've got other things like these are also inverses of each other, squares and square roots, right? All that kind of stuff. Well, exponentials and logarithms are inverses of each other, and we're going to use the two to solve. Not this section, but later sections. Okay, so we also saw that this is the same as this, right? That a radical is the different form is just exponential, okay? So we're going to have a similar conversion here with logs. So if we have a to the b is equal to c, its transformation into a log form is log base a to the c is b. Okay, so these are the same thing. All right. Now, let's talk about our bases for logs. Logs can come in any base, but we're going to concentrate on base 10 and base e. All right. So, do you see how this is set up? It says log, that's a logarithm, of base a of c is equal to some number b. Right? Now look at this one. Where is my base a? It doesn't have one down there, does it? No, I don't see one. Okay, so that is a base 10, which is called a common log. All right, and there really is a 10 there. Okay, log base 10 of 10 to the 18th power. That's really what it says. It's kind of like square roots. We don't put the 2 in there, but there really is a 2 in there. It's kind of the same thing here. We just never write the 10 in there. So if it's just this kind of a log with nothing, you assume that it's a 10. Okay, common log. Well, we have a common log button right here. This is base 10 only. All right, so if I hit the log of 10 raised to the 18th power, I get 18. Okay, why is that? Well, let's take a look at it exponentially, and it'll show itself here. So I'm going to write down with the base 18 equals b, right? And I'm going to convert it over here. So I've got 10 raised to the b power is equal to c, which is 10 to the 18th power. C is this piece, a is that piece, and b is b. Well, 10 to what power is equal to 10 to the 18th power? Well, b has to be 18, right? That's where I got this from. That's what the calculator's doing. Okay? So you can see it pretty well when you turn it into an exponential, and that's going to be the key to solving logs and exponentials. Is if you get stuck as a logarithm, you can't do anything with it, then you change it over to an exponential form. If you get stuck as an exponential, then you change it over to a log form. One or the others will always work, kind of like what we were doing up in here. Okay? So here, same thing. We've got log base 10 of 10 to the 6.2 is equal to b. So now we have 10 to the b is equal to 10 to the 6.2 power. So b has to be 6.2. Okay? And logarithms are used in all kinds of stuff. One of the more common ones would be the Richter scale. I have to sneeze. Excuse me. pH balances in acidity levels, stuff like that. That's all logarithmic. A lot of things. The decibel scale for hearing is logarithmic. We're not going to get into any of those applications though. Okay, so that was our common log. Now, if we have a base of e, it's called a natural log. That's where that's where the e comes into play. Okay, and so these all look like this without this, and these all look like an ln, log natural. I don't know why they call it a natural log and then split that, but anyway, ln e to the fifth is really ln base e to the fifth. Okay, we're using the same thing here. So we're going to say that the log base e of e to the fifth is b. And so now over here we have e to the b is equal to e to the fifth. E to the b is equal to e to the fifth. So b has to be 5. I don't even need a calculator for that. Okay? It's got to be 5. Let's try it on a calculator. We have two types. We have the common log, which is exactly a base 10, and we have the natural log, which is a base e. So we can use that, and we want to raise e to the x to the fifth power. 5. Okay? Same thing here. What would be your answer? Negative 6x. Good job. You can throw it in here like that. Okay, natural log of 31. Well, that's pretty darn easy. Just use a calculator. 3.434. Let's try that. And what is this? That's a squiggle. It's not an equals. ln 31 is a squiggle of 3.434. What does that mean? The squiggle right here means approximately. That's because we're rounding. Okay? Sometimes I've seen it more often like that than this. This is kind of a congruency kind of a thing too, so it depends on what you're working with. Nothing new here, right? We've got just division, 6/7. Okay. Negative 1.4. Piece of cake. What's my base? 4, right? This is not a common log or a natural log. And I don't have any other buttons other than a log to the base of 10 and a log to the base of e. Here I have a log of the base to 4. So I have to go about it this way. Okay, so that's why I've been showing you how to convert. Let me just try something here. Just want to get rid of all of this so I can go underneath there again. All right, so I want to go underneath this conversion. All right, so if I have log base 4 of 4 to the third is equal to b, see a is 4, c is 4 to the third, and b is b. Then I have a to the b power is equal to c. 4 to some power is equal to 4 to the third. Well, doesn't b have to be 3 in order for that statement to be true? This is the only thing that's true. So b has to be 3. Look at how easy it is when you convert it over to an exponential. Logarithmically, it looks like a nightmare, but it's really not. Okay. Now I have a base 3. I'm going to go underneath this again. So I have log base 3 of 9 is equal to b, some number, right? We're saying, what is this equal to? Again, I don't have these correct buttons. Okay, so I'm going to turn it into an exponential by saying 3 to the b is 9, right? 3 to the b is 9. I'm using this right here. Well, what 3 to what power is going to be 9? Isn't it 2? Isn't this the true statement right there? Yep, so your answer is 2. So sometimes we have to use logic skills on trying to figure these out. One more. Boy, these are short lectures. I love it. I bet you are just thrilled as well. There's your starting spot. So 2 to the b is equal to a 16th. All right. Well, this one's a tad bit tougher. Let's first of all find out if I had, I know I don't, but let's just say I had this. 2 to the what power is going to give me 16? Well, I can start playing around with, you know, powers, right? I know that it's 4. 2 to the 4th power is 16. So here it would have to be 4. But I don't have a 16, I have a 1/16, right? So how do I move this underneath? Well, wouldn't that be a negative? If b to the 4, 2 to the 4th is 16, then 2 to the negative 4 is 1 over 2 to the 4th, based on my properties of exponentials, right? We know this. And then this is 1/16. So if it's underneath like that, it's got to have a negative exponent on it. So this one's negative 4. See how that works? Just a little bit of logic. And we're done. So that's it for the first 3 sections. Like I said, we are just skimming the surface here. You're just going to get a real brief introduction into exponentials and logs. We're going to start solving next, and then playing around with forms and all that kind of stuff. So I'll see you for that. And don't forget, you know, you need to be studying for the final at this point. Those 2 things are open at the same time. So do a little bit of work in here. Now all these problems from chapter 12 will appear in the final exam. Even though you don't have a final test on it, they will appear in the final exam. So you've got to make sure that you are doing these, right? And so you kind of have double duty going on right now. That's why I've kept this so late. So, all right, I'll see you in a bit.